Good morning, guys, or afternoon, depending on when you're watching this. Today, we are starting a new lesson, which is finding distance on the coordinate plane. Okay, so we've learned how to use the coordinate plane and how to graph, and today we're going to find distance on the coordinate plane. So, how far apart different numbers are. So these are the things that we need to be able to do. Our main goal is going to be able to define distance between 2 points. Okay, that's the main goal. To be able to achieve that goal, this is our checklist. First, you need to be able to graph points in the coordinate plane. So go over and up or down, graph them. We also need to be able to count the distance between 2 points. So if you have a point here and a point here on the coordinate plane, you should be able to count how far across they are. We need to be able to identify ordered pairs. So when we see something graphed, we should be able to write it as x value then y value. We need to be able to identify absolute value of a number. Absolute value is when you have bars around a number and you make it positive. It is distance from 0. We need to be able to add absolute values. So make more than one thing positive and then add them together. And we need to be able to use absolute values to find distance on the coordinate plane in cases where we cannot count the boxes. So it's a pretty hefty to-do list, but we are going to actually get this done pretty quickly. Today's topic is, I would say, easier than the topic we just learned. So here we go. First thing we're going to do is we're going to watch the Savas Realize video, which is going to explain and kind of pre-teach the concept to us. I know the sound doesn't really work well on Screencastify for these videos, so if you need to go to your own Savas Realize, you can go to your own Savas Realize and find the same example. So here it goes. How can you find the distance between 2 points on a coordinate plane? Think about this question during the lesson. Tammy drew a map of her neighborhood. How far is it from Lee's house to the school? Okay, so I'm going to stop right here. We basically want to know how far apart Lee's house is from the school. So one way to do this, oops, you may not have been able to hear me. One way to do this is to simply count how far apart those dots are. And I like to think of it like bunny hops. You're going to bunny hop from the dot on each line to the next dot. So I have 1 hop, 2 hops, 3 hops, 4 hops, 5 hops to get to the next dot. That means they're 5 miles apart. Now that is the most basic way to find distance on the coordinate plane, is to count the bunny hops from dot to dot. They're going to show us another way, a more sophisticated mathematical way, using the coordinates to find distance. Are Lee's house and the school on the same horizontal or vertical grid line? Lee's house and the school are on the same vertical grid line. Find the coordinates of Lee's house and the school. How do you find the ordered pairs for Lee's house and the school? For each location, start at the origin and move along the x-axis and then along the y-axis. Then record the coordinates as an ordered pair. What are the coordinates for Lee's house? Okay, so we have a couple of options. Remember, when you count coordinates, you always start at the origin. So I always start here, and I go backwards to get to Lee's house. You go over first. So I have to go over 1, 2, 3, 4. And then I have to go down to get to Lee's house. 1, 2, 3. So I went to the left 4, which is -4, and I went down 3, which is -3. So you should have picked this coordinate to be the coordinate for Lee's house. So let me erase this, and we'll move it up and keep going. The coordinates for Lee's house are -4, -3. The coordinates for the school are -4, 2. What do you notice about the x-coordinates of Lee's house and the school? The x-coordinates are the same. Because the x-coordinates are the same, you can use the y-coordinates to find the distance between
use what you know about absolute value to find distances. The absolute values of the y-coordinates tell you the distance between each point and the x-axis. This distance is the absolute value of 2, or 2. This distance is the absolute value of -3, or 3. The distance from Lee's house to school is the absolute value of 2 plus the absolute value of -3 equals 2 plus 3 equals 5 miles. Why do you add the distances between each point and the x-axis to find the total distance from Lee's house to the school?
Alright, so what I want to do is I want to kind of go over what they just said because they said a whole lot of words and you might be a little bit confused. So what we're going to do is we're going to look at the position of the school. The school, if you notice, is 2 spaces above the axis, above this x-axis, and that's like the 0 line. And then if you look over here at the Lee's house is 1, 2, 3 spaces below the line. So we're talking about distance. We have 2 up, 3 down. Distance is always positive. So total distance between the school and Lee's house means you're going to add those absolute values, which means make them positive, and you're going to get 5. That is what they just did. They took the absolute values, which were bars, they made it positive, and then they added them to find the total distance from the school to Lee's house. Now, you don't always add them, and we're going to see examples where you would subtract them here in a second. So let me erase this and continue to play the video.
You add the distances between each point and the x-axis because the two distances combined result in the total distance between Lee's house and the school.
Okay, so let's look at this activity. They're going to give us 2 dots that we can move around. So right now, if you notice these 2 dots, you can tell they're 1 space away. Well, I'll show you what that means. If you look at the ordered pairs, I get rid of the one that matches. They both have a +4. I don't need that. We're going to focus on the differing coordinates. One was -5, one was -4. We have this rule that says if they're different, if one's dot's over here and one dot's over here, if they're on different sides or are different signs, you would add them. If they're the same side, if you notice these dots are on the same side and the same sign, negative and negative, you subtract. So I'm going to do 5 minus 4 is 1. That's why they're 1 space apart. Now if I put it over here, I'm going to move this B all the way over here. Trying to anyway. Now look at it. When you look at the values that are different, I have a -5 and a +1. Those are different. One is negative and one's positive. Different means add. So make them positive. 5, 1, add them, and it's 6 units apart. And if you counted, they're 6 apart. So if they're on the same side of the coordinate plane, you would subtract them. If they're on different sides, you add. And we're going to see that more reinforced more as we continue on our lesson. So now what we did as a class is we worked through some pair deck problems. Since you're watching the replay, you're probably going to need some pencil and paper. I'm going to go back to my slides. So what we did first was we checked comprehension. We wanted to see if they could apply what they watched in the video. So here's our question. And the question says, what is the distance from Lee's house? So here's Lee's house to the playground, which is up here. And you're going from dot to dot. So I want you to take a second and I want you to count how far away those 2 places are. Pause and then come back. So if you count, you go from dot to dot and you do bunny hops along each line. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8. They are 8 miles apart. 8 miles apart. Another way to think about this is to break it into 2 parts. The playground is 1, 2, 3, 4, 5. It was 5 above the x-axis. And then we have Lee's house is 1, 2, 3 below the x-axis. So since we have 5 and we have 3, I'm going to add those together. 5 above, 3 below means a total of 8 miles apart. Now, check this against our rule. If they're on different sides, you add. They were on different sides, so we did add those. If they were the same size, same side, you would subtract. So it should be 8 miles. Let's practice another one. Erase, erase, erase. Erase, erase, erase. All right. This next one wants us to find the distance from the school, so school, to the playground. So pause right now and figure out how far apart they are. If you count from dot to dot doing bunny hops, you have 1, 2, 3. They are 3 miles apart. Now, if you look at their ordered pairs, you ignore what matches and you only focus on the 2 other numbers. Remember, different sides add, same side subtract. S and S, same subtract. These are on the same side of an axis. They also are the same because they're both positive. That means you subtract. 5 minus 2 equals 3. Okay, let's try another one. I gotta erase all these. Okay. Now what we have is we have an example that doesn't have grid lines. So, oh no, we can't just count bunny hops anymore. We have to rely on some mathematical rules. So this says the Coulter family wants to take a day trip to the water park. How far is it from their home all the way to the water park? Well, we're going to focus solely on the ordered pairs. When you look at these 2 ordered pairs, you should notice they both have a negative 40 and a negative 40. You are going to ignore the numbers that match and focus on the numbers that are different. Well, one way to do this is to remember if they're on different sides, you add. If they're on the same side, you subtract. Well, these 2 locations are on different sides of my y-axis, so I need to be adding them together. Remember, we only deal with the positive values, so I'm going to do 85.5 plus 65.5. I'm going to use my knowledge of adding decimals or a calculator, and I would get 151 miles. Okay, the reason is because the Coulter's home is 65.5 miles to the right of my center line, and the water park is 85.5 miles to the left. So total, you need to add those. You would add them and get 151. Different sides you add, same sides you would subtract. And we're only dealing with positive values because distance is always positive. You can't run negative 2 miles. So here's the Coulter family again. It says they made it to the rest stop. So here they are, they're at the rest stop. And they decide to stop for lunch there. How much further do they have to go to get to the water park? So we want to know how far apart these 2 places are. So when you look at the 2 coordinates, we're going to mark out negative 40 because those match. I'm not interested in the numbers that match. I want to look at the other 2 numbers. So if they are on different sides, we add. Are these on different sides? No, they're the same side. So same side, we subtract. So I'm going to do 85.5 minus 25.75. Okay, remember, we're only dealing with positive versions. So this is going to be based on a lot of borrowing unless you use a calculator. Either way is fine by me. You would get 59.75 miles. That's how far apart those are. And I subtracted them because they were on the same side. They were both negative. Now the next one you're going to do on your own. So I'll read the problem to you and then you're going to have to pause it and see if you can figure out the correct answer. So here it goes. It says they had a blast at the water park and now they're ready to head back home. They stop at the rest stop for some gas and then they head home. We want to know how far apart the rest stop is from the Coulter's home. So pause the video and see if you can figure that out. Okay, so we're going to mark out the -40s because those match. I'm not interested in those. And I need to remember different sides add, same side subtract. Well, when I look at these, they're on different sides. One's negative, one's positive. So different sides means add. So I'm going to do 25.75 plus 65.5. Now I'm running out of room to add those, showing all of my work. So when you add them, you would get, I'm going to use a calculator, 91.25 miles. Remember, we added them because they're on different sides, and distance has everything positive. So that is when you have a picture, but you don't have grid lines to count. The next examples we're going to see aren't going to have a picture at all. So you're only going to be able to rely on the coordinates. Okay, here we go. So this one says find the distance between these 2 points. Well, the first thing you have to look for is what coordinates match. -5 and -5 match. So I only want to focus on 2 and 6. Remember your rule. Different sides add, same sides subtract. Well, these are both positive, so they're the same side. So I need to subtract. 6 minus 2 is 4. They are 4 units apart. So you're going to try the next two, which means you're going to pause, and you can rewind and rewatch this if you need to see exactly what we did, because it is moving kind of fast. I want you to find the distance between these 2 points. Remember, different sides add, same sides subtract. S and S go together. So pause and work it out. All right, so when you look at this, the -6's get the axe because they're the same. I'm looking at 5 and 2. Those are same. They're both positive. They're the same side. So I need to subtract. 5 take away 2 equals 3. They are 3 units apart. One last question. Erasey, erasey, erasey. And once again, it's one that you're doing, so you will need to pause it. Okay. Find the distance between those 2 points, pause, and then come back. Remember, different sides add, same sides subtract. So when you look at this, the 8s match, so I'm going to get rid of those. And I have a -2 and a 7. Well, those are different. One's positive, one's negative, so I need to add them. Remember, add their positive versions. 2 plus 7 is 9. They are 9 spaces apart. Now, your assignment for today is in Savvis Realize, so you need to go to your waffle and to Easy Bridge because this lesson was easy, and to Savvis Realize. Your homework assignment is 2-5. 2-5 is your homework assignment. Hit me up for office hours if you need help. Bye.